Welcome to the Montgomery County Public Schools Algebra 2B Semester Exam Review video. I will be talking to you about Unit 6, which is the last two pages of the packet, page 21 and 22, probably the most recent material that you've been working on, so most likely the easiest stuff for you to remember. Alright, so let's take a look at that. Unit 6. Here it says the lifespan of a certain insect is normally distributed with a mean of 14 days and a standard deviation of 2 days. All right, what percentage of the population has a lifespan between 12 and 16 days? Well, in order for me to address this problem, I need to decide whether I'm going to use a z-table or the empirical rule. So it's very helpful for me. Well, I've already told you I'm a visual learner, so I would like to see my my bell curve. Excuse me. So let's go ahead and identify what we have. We know that the mean is 14 days. So 14 days is a lifespan of some insects. All right, and it has a standard deviation of 2. So I'm going to go ahead and draw 1 standard deviation, 2 standard deviations, 3. This is not exact, but it's close enough for government work. All right, here we have 16, 18, 20. And the other way, if I have it right, we're increasing by 1 standard deviation, 2, 3, and go backwards. So 12, 10, and 8. All right, so now we have this kind of idea of what's going on. Also, I want to point out on the formula sheet, you will be given this beautiful bell curve with standard deviations 1, 2, 3 and percentages. So that's going to help us out when we're doing these problems. If our numbers lie on exact values, exact number of deviations away from the mean. Okay, so now we've got that set up, we are ready to go. I might label this a little differently so I can see it's the center. All right, what percentage of the population has a lifespan between 12 and 16 days? Oh, well, look right there. I see 12 and 16. Well, that's easy. This is 34 and 34. In total, 1 deviation away from the mean has 68% of the data. If I wasn't sure or I forgot, I could double check here and add up those 2%. All right, you know what? I'm going to make a little copy of that so I don't keep going back and forth. All right. So what percentage of the population has a lifespan greater than 18 days? So I'm going to go here and say, okay, 18 days. Well, this would be 0, 1, 2. That's 2 deviations above the mean. And I want to know greater than 18 days. So anything here, if I was going to shade, anything that's here, well, I'm going to go to my empirical rule data here, and I'm going to look, okay, 2 deviations above the mean. What percent is above? Well, this is 2.35, and this is 0.15. So if I add that together, I get 2.5%. All right. What percentage of the population has a lifespan between 14 and 20 days? So 14 and 20. Between, so I'm not going further than stopping at 20. So 1, 2, 3 deviations. So from 0, 1, 2, 3. So I'm stopping here. I'm adding 2.35 plus 13.5 plus 34. And add those 3 up. And I end up, oh, should I write that out? 34 plus 13.5 plus 2.35, and I end up with 49.85% of the data between those 2 days. All right, what percentage of the population has a lifespan less than 12 days? So here's 12 days and less, and if I add these 3 up, I will see that I have 0.15, that little tiny bit there, plus 2.35, plus 13.5. Right, so I'm adding this, this, and this. Again, I could reference this and add those guys up. All right, and in total that is 16% of the data. Wonderful. A particular insect lived for 24 days. Wow, I don't even see this. Okay, 20, if I keep going, 22, 24. Wow. Okay, so 1, 2, 3, 4, 5. It looks like it's 5 standard deviations above the mean. Did this insect live unusually long? Use what you know about standard deviation to explain your answer. So I would say definitely, it's very, very, very rare, right? The percent is something beyond what I can calculate with my empirical rule. It's such a low percentage of insect life. A particular insect lived for 24 days. Did this insect live unusually long? Yes, it did. Use what you know about standard deviations to explain your answer. Okay. Most of the data lies within 3 standard deviations of the mean. I said most, but you guys actually know a percent. What percent of data lies within 3 standard deviations? To be exact, 99.7. Now I say to be exact. Haha, that's kind of funny because all of this is really an approximation. We're approximating, so I can't be exact. But approximately 99.7% of the data lies within 3 standard deviations of the mean. But this insect is living 5 standard deviations above the mean, which means it's very rare. It's very unusual for that to happen. All right, next page. The graph shows a normal distribution, A, with a mean of 15 and a standard deviation of 1. To its right is the normal distribution B, and we want to complete the blanks. Complete the blanks below with greater than, less than, or equal to. The standard deviation of distribution B, so the standard deviation is greater than, less than, or equal to the standard deviation of distribution A. So I'm going to put greater than, less than, equal to. So we have to decide which one we're talking about. Okay, so the standard deviation, the spread of the data on B, is that a bigger spread or a smaller spread than A? So A standard deviation, 1 standard deviation away from the mean should hold about 68% of the data. Over here, if I wanted 68% of the data, I have to go much wider out. So standard deviation is definitely larger on B, so it's greater than. So you would write greater than. And here, the mean of the distribution B, so well, the mean here is 15, and the mean here is much higher than 15. Right? It's 21, so it's also greater than. All right, so here we're just comparing the shape, the center, and the spread. Right? The mean, median, mode of our normal curve, which lies right there in the center. All right, which statement is true about a normal distribution? Select all that apply. The graph has a vertical axis of symmetry at the mean. So let's think about this. If this is my mean right here, that's my mean. It has a vertical symmetry at the mean. Does this side, if we folded this, would they match up? Yeah, so that's a true statement. Okay. There's one mode located at the mean, median, and mode. Okay, there's one mode, meaning it only has one peak, one place where it had the highest number of entries. And that is also true. It's not bimodal, right? It doesn't have 2 modes. It only has 1. Okay? And the mean, median, and mode all lie right there. All right. Approximately 68% of the data lie within 1 standard deviation of the mean. Yeah, we were just talking about that. 1 deviation away, and here you've got about 68%. That is true. Right? Because we said this was 34 and 34. Approximately. This is about. This is why we have this word here. Okay. A data score with a z-score of 3. 1, 2, 3. Okay, so we have one data score here. Is further from the mean. Here's my mean. and 0. Then the data score with a z-score of -2. -1, -2. So here we have 2 this way, here we have 3 that way. Which of those is further from the mean? We would say that the 3 is definitely further. So a data score with a z-score of 3 is further from the mean than the data score of -2, which would also be a true statement. They are all true. Wow. All right. Wonderful. Okay. We have 2 more questions. And these are great questions. They're asking you to take all the stuff that you've learned and put it all together. So, the president of Small Mart is awarding Store of the Year to one of 2 stores. He will give the award to the store that did the best relative to the stores in their respective cities. So here's the information that the president has. So we have 2 cities. So really good idea is to make sure you understand there's a lot of data given here. And if you don't understand what's going on or what it all means, it's really hard to answer the question. So let's make sure we understand. So city, we have LA and Milwaukee. The mean sales for all the stores in that city, so LA had a mean of this. So I'm going to write a little mu here. The mean is that, right? So keyword there. This is giving us the mean for LA and the mean for Milwaukee. All right, then here we have standard deviation. So I'm going to put a little sigma there because that's what we've been using for standard deviation. Now I'm making it look silly. All right. Standard deviation in sales for all the stores in the city. So this, again, is standard deviation for LA and for Milwaukee. The store with the highest sales in the city was Goldie's store and Ahmed's store. All right. And the sales for the store was this. So this seems like a data point to me. So I'm going to label that actually data point. Okay. So I have a data point, I have my mean, my standard deviation, and I want to know, respectively, like to their cities, who should receive the award, who did better. Okay, which store should receive the award? Now I think it's a really good idea to organize your information. There's a lot of information. So I'm going to organize it by name. So Goldie's store and Ahmed's store. So I'm just going to do this so I kind of can organize my paper and know what's going on. I'm going to shift this up a little bit. All right. So, which one should receive the award? So, I think the first thing to do is to find the z-score for each so that we can compare and see, okay, well, where is it on a standard normal curve, right? If we make a standard, then we can compare them. It's hard to compare if we just said, oh, who did better? Well, obviously Goldie, because she brought in 25.9 million and Ahmed only brought in 17.9 million. But if you look at their means, well, they're both above the mean. So we want to really be able to compare it better. So we need to normalize it. Okay, so we're going to write the z-score. Now z-score formula is right here on your formula sheet. So we have data score minus the mean over standard deviation. If you need that, remember it's on your formula sheet. Okay, so we have data point for Goldie store is 25.9. I'm going to leave it in millions. Everything is in millions, so we're going to just leave it like that. I'm not going to write a bunch of zeros. That would just make it a little bit harder for me to keep track of everything. So I put my data score minus the mean divided by the standard deviation, 2.2. Okay, so that will give me my z-score for Goldie score. And z-score for Ahmed, let's see, 17.9 minus the mean, 15.1, divided by the standard deviation, 1.4. Okay. This will tell me how far above or below the mean we are. Alright, so when we do this, we get that this one is approximately, and I had to round, and I want to round to 2 places after the decimal, because if I want to go look at the chart to find percentages, well, I guess it's not necessary to do that, but At Goldie's store, it looks like it was 1.5, and at Ahmed's, it was 2. All right. So the question is, which store should receive the award? So if I put these on the same normalized curve, 0 is the mean, 1, 1.5, I'm sorry, 1, 2. So we have Ahmed here and Goldie here. Even though Goldie brought in so much more money, Ahmed did better with respect to the stores in his area. All right, so we would say because it's further away from the mean, Ahmed's store should win. Because it is higher above the mean. I was just thinking about this. I'd actually prefer not to write that and give more detailed information. I don't know that it's expected, but we can look at the table, and I just realized I don't have a table here to look at. Okay. All right, now we can look at the table so we can talk about this better. So here we have a z-score of 2, and here we have a z-score of 1.5. Once we have that z-score, we can go and look at our table and say, okay, a z-score, these are positive, these are negative z-scores, so a z-score of 1.5 has 9.9332, okay? So 0.9332, or 93.32% of the stores are below. So, yes. Okay, so Goldie's store did better than 93.32% of the stores. Okay, but now we want to look at Ahmed's store and see, okay, well, if you had a z-score of 2, it means that 97.72% is below. So that means Ahmed did better than, it was 0.9772. So Ahmed did better than, so I think this would be a better statement to say. Ahmed's store should win his store did better than 97.72% of the stores. All right, wonderful. And then I think the next page has almost a very, very similar type of problem. So let's try that one. All right, wonderful. So here it says the president of Small Mart is also going to fire the manager of the store that has performed the worst during the past year relative to the other stores in 2 other cities. So here is the information that the president has. So in New York and Seattle, the mean sales are 52 million and 30 million. The standard deviations are here. The store with the highest sales are Jose's store and Jamal's store. And the sales were this. So again, these are our data points that were given. These are our data points. All right. So which store will have its manager fired? Oh no. Okay. So again, I'm going to organize my data. So Jose's store and Jamal's store. And we have our data points. We want to find our z-score. So for Jose's store, it would be 31.7 minus the mean, which is this guy, 52.9, and divided by standard deviation, 6.3. Right, so I'm just looking at these data pieces for Jose. Okay, and then I can calculate that. And then Jamal's store, he had 14.4 minus the mean, 30.2, divided by 4. All right, and then we want to find the z-score for that. Okay, when you calculate it, it looks like here we are at negative 3.365, so I would want to round that up to 6 here, I'll put 6.5. So I'd round that to 3.7. Z-score is about that. All right, and at Jamal's store, we're at about negative 3.95. We'd like that approximate because I rounded. All right. Wow. So if we look at data about this, if I wanted to go and get some percents, negative 3.37, oh my gosh, negative 3.37 is right here, 0.0004. So that is not even 1%. So almost everybody is doing better than this store. All right. So if we looked at a number line, I'm trying to think how to explain this. Okay, if we looked at a number line, this guy, right, if we look at our scores, this is 0, -1, -2, -3, -4. Here at Jamal's store, we're closer to -4. We're closer to -4, and here we're closer to -3. So which store is doing worse would be the one that's closer to -4. That would definitely be the store that's doing worse. It's further away from the mean. So it looks like Jamal's manager is going to get fired. Jamal's store will have the manager fired. I hope they do a analysis and check to see if is it really just the manager or are there other issues. Jamal's store will have the manager fired. All right. Wonderful. Thank you guys for watching the video for Unit 6, and hopefully this was the most fresh stuff in your mind, so it was comfortable for you. All right. Happy studying and do your best on the final exam.